Can I welcome Rizchel Dayao? Or did I pronounce that correctly?
Rizchel Dayao.
Rizchel Dayao. All the way originally from Arizona, where it's just as hot apparently, so this heat is nothing. This heat is cool. And Rizchel is going to be presenting building enterprise level applications with the magic of React, Redux, and GraphQL. Rizchel, the floor is yours. Welcome to Athens.
Thank you. Thank you for having me. Okay, so again, I'm Rizchel Dayao, and I'm from the US, if you can't tell by my accent. But today I'll be talking about building enterprise applications with React, Redux, GraphQL, a couple of testing tools, and then at the end I'll be wrapping up with how to deploy that application on Kubernetes. So a little bit about me. I was previously a front-end developer and a front-end developer lead, which is what I'll be talking about today on the IBM Cloud, if any of you are familiar with that. Now I'm a developer advocate, so I focus more on containers and Kubernetes. But yeah, so I'll be talking mostly about my front-end experience and kind of how we built this application. And then just a fun fact is this picture was taken where James Bond Skyfall was filmed, if any of you guys have seen that, in the Scottish Highlands. So let's get straight into it. Building enterprise applications is hard. From the start to the end, every piece of it, especially if you haven't done it before. So I was given a task to build and architect this front-end microservice, having no knowledge, having knowledge of front-end before, but no architect experience, really. So it's a lot of pressure when you kind of get this big task in front of you. And at the end of it, I thought it was difficult, but I persevered through it, and we came out with a great product. And with any development, it can sometimes make you feel like a queen or king when you're on a roll, so developing or just starting out. But then you also have these kind of moments, which I'm sure a lot of you have felt like throwing your computer out a window. I've definitely had those moments. And one of the most challenging tasks is designing the architecture and the setup. So when you first get tasked with building a microservice or just a product for your company, the first thing you think about is architecture. So how do you come up with code and a foundation that's going to last a long time, especially in technology? New technology comes out all the time, so it's hard to build something that's going to be long-lasting and that all developers will like developing. So if you take a look at this picture, it's the Notre Dame. So if you think about that architecture and that foundation, how long that took, and it's been around for hundreds of years. So it's a little bit different than software, but it's kind of the same idea. With software, we want something that lasts a long time, that our users likes, has a good experience, and that everyone can enjoy. And there are many things to consider when we first start building an architecture. So first off, the first question is, what developer tools best meet our needs? So these can be things like languages. So if you have a front end, or if you're working on back end, the language you get a smaller group. But you still have to choose what's best for you and your team, as well as libraries. A lot of libraries like React or Angular, it has a lot of overhead. So you have to consider that when you're building something. Can you maybe have a little give on performance for what it's going to give back? Or is vanilla JavaScript the best way to go? And then other tools like DevOps. So if we think about continuous integration, continuous development, those tools we have to think of as well as like build tools. So it's kind of all these things you have to think about at first. And then next, how do we manage our internal and external data within our microservice? So I'll specifically be talking about a microservice architecture, just because that's how IBM Cloud was built. So I'll be talking about microservices a lot. But usually enterprise applications have a lot of data, and it has a lot of data internally that you have to manage, and it has external data. So external data can come from other microservices, it can come from APIs, but you have to figure a way to manage that nicely so your code doesn't get all messed up and that if someone does come on your team, they can understand what's going on. And then next, how do we maintain clean and consistent code? So I don't think anyone goes out there and wants to write bad code, or I hope no one does. But at the beginning, we want to find a way to help developers make it easier for them to write clean and consistent code. Everyone wants to write clean code, but if we can, put in linting tests, if we can put in more those kind of tests, it's going to make it easier for them to write this clean code. And then how do we create a consistent way to configure and deploy all of our microservices? So within the IBM Cloud, we have the front and the back end, but the front end, I think, is over probably 10 microservices. I don't know the exact number. So we have a lot of services, so each of those are microservice, as well as each part of the platform, which would be like accounts, billing, anything like that. So it's a pretty big thing that you need to get deployed, and if a different team is working on each part, you need to have a consistent way to deploy it, so not each team kind of has to relearn every time they want to deploy a new microservice. And just these questions, it is a little overwhelming when you're kind of thinking about it. When I was given my task, I was a little overwhelmed, and I think that's just with anything. So like I said before, our team was tasked to create a new front-end microservice. And this is a screenshot of the design. Well, so this is in production now, but this is a screenshot of kind of what our designer came with us for. So previously, just a little bit of history. SoftLayer was acquired by IBM a few years ago, and they provide a lot of our infrastructure services. So you can order like bare metal, servers, virtual machines, anything like that. The problem with that was we kind of had two different platforms, a SoftLayer platform and an IBM Cloud platform. But we wanted to unify the experience so people didn't feel like we were two different companies. So this particular task that we were given was to bring in the old virtual server experience, also known as virtual machines. At IBM, we call them virtual servers. But yes, so to bring it into IBM Cloud so we could have one unified experience and it didn't feel too segregated. But like any projects, we had certain requirements to fulfill. So was this even possible to integrate SoftLayer APIs into the IBM Cloud platform? So at the time that I was given this task to lead this team, I was just a front-end developer. I'd been with IBM for a little while, but basically my manager came up to me and said, hey, would you like to lead this team for this really cool project? It's kind of going to be the first microservice to pull in from SoftLayer, but then they want to do it with more SoftLayer services. But what he didn't tell me at first was for the last 2 years, SoftLayer was saying this was impossible to do in the IBM Cloud. So that was great to get as kind of my first task. Basically, they were saying that the APIs couldn't work in IBM Cloud. So about after a week, I got it to work. So after that 2 years of people saying we couldn't do it, I proved that we could, and then we quickly got a team together and started putting in more requirements and kind of laying out our roadmap. So the next was that we had to have this new microservice fit into the existing ecosystem. So because we already had an existing infrastructure, we couldn't just create like a totally new way to do a microservice, because if every microservice was configured differently, that gets really confusing. And a lot of the teams switch from these different microservices. So if we have a consistent way, then those developers don't have to learn a new way to configure it or run this microservice. And then it had to consume both IBM Cloud and SoftLayer APIs. So we just had to find a way for them to work together, if they could work together, and then do that cleanly. And then last, so this was made more by us developers. We wanted a testing and component-based architecture. So many of the microservices before we built this had no testing, which introduced a lot of bugs. And every time we had to debug something, we had to go through like thousands of lines of code. So we wanted this to be tested from the start. So at least it could prevent, more bugs. We'll probably still have a couple, but we were trying to make it so to have the least amount possible. And then the component-based architecture. So on that design you saw, you can easily break it down into components, and then we wanted this to have a more modular architecture, as well as that design has changed a few times since we first got it, which, designs are always changing. So if we had it in components, it was easier for us to go in and make changes and find bugs instead of like having one or two really big files of all the code. So challenge number 1, what developer tools best meets our needs? So we went with React. So that was the library we chose. Because it was a pretty big microservice, we were willing to take on that big file of React for the benefits that it gave us. If you're doing a smaller microservice, it might not always make sense, but this was a pretty big one. And then we used ES6. So at the time we were building this, it was supported by the browsers that IBM Cloud supported. It was the newest that had the most support that we wanted to use. And then Express. So all the other microservices had an Express server side, and we kind of just wanted to stay with the same server side. We didn't want to create a new code base for that. We kind of just copy and pasted it from another microservice. And then last, Webpack, which is the build tool for React that works really well. So we went with that choice. So why did we choose React? So the first thing is it has reusable components. So our requirement for having a component-based architecture, that met it fully. And then with these components, you could just reuse them in multiple places. And I'll kind of go into more of that in the next slide. And then the next one, it had fast render with the virtual DOM, which I'll go into the virtual DOM in the next slide. But we wanted to have a fast render because on that form, depending on what you chose as your options, it basically changed all the other options a user could choose. So the page is always changing depending on the user's options. And then next we had Redux state management. So there was a lot of internal data that we had to manage, as well as external data. Redux works really well with React. It also works with other libraries as well. So it's not just for React, but it works really well with React. And then next, data binding. So this was, I think, more of a developer decision. So React has one-way data binding, which means that the data needs to come from the parent to the child. The child can't manipulate a state or a prop and pass it back up. So like if you're familiar with Angular, it has two-way data binding. So with this, a lot of us were new to React at the time. So we thought it would just be easier just to have that one-way data binding, cause less issues with all the code we had to do. And then last, the Carbon Components library. So IBM has a design and component library. It's open sourced. Anyone can use it, but its main customer is for IBM Cloud. So for Carbon Components, it has a vanilla JavaScript version, but it also has a React version. We didn't want to do this in vanilla JavaScript, so because it had support for that, that's another reason why we went with React, because we didn't have to build a lot of these components from the ground up. So what's React? React is a JavaScript library for building user interfaces. So first, it functions as the view layer. So if you're thinking of the MVC model view controller architecture, it mainly functions as the view layer. Next, it's component-based. So everything that you build in React is going to be a component, and those components make up whatever your application you're building. And then it has the virtual DOM. So with the virtual DOM is basically an abstraction of your DOM, and any changes that are made, any differences that are made between your virtual DOM and your DOM, that's the only thing it will re-render. So if you have a lot of things changing on your page, it's really good because it doesn't have to re-render the page for every change. It only re-renders the differences. And then it has JSX syntax. So this syntax is JavaScript, but it has HTML syntax within it. So instead of having to always go from like HTML, CSS to JavaScript, you kind of have it all in one file, which some people like, and I know some people don't. But for us, it worked well, and we liked being able to see all of that. So imagine we're building a house like an application. I'm going to explain React through this. But in the US, so you can basically buy a home and build it from the ground up. So that's kind of what I'm going to journey through with you guys in these next couple slides. So that house, so in this pyramid on the bottom, we have the house, which would be the application. So that contains all your microservices, everything that needs to run this application, all your configurations. Each room would then be a microservice. And microservices are modular, loosely coupled services. So if you have like a kitchen, a living room, a bedroom, imagine those all as different microservices. And then next you have your appliances. So appliances can be like a washer and dryer or a stove or anything like that. But those would be our containers. And in the containers, that's what handles all the state and all the data. And then the components are independent reusable elements. So those are more presentational. They're not going to have any logic or data in it. It's just going to be for presentational use. So if we look at this, we have the stove. So if we choose the stove as the container, then if you think about it, that's what the user interacts with. That's how the user turns like a stove burner on and everything. So that controls all the data and logic and passes it down to the components. And our components would be, for example, a stove burner. Someone doesn't go in and just turn on the stove burner. They have to do it through the stove, which then turns on the burner. So for the containers in the stove, so it's made up of smaller parts. So it has knobs, as stove burners. It's made up of a lot of reusable parts. If we think about a stove burner, there's usually 2 to 4, but they're only presentational, and you can use it multiple times. Same thing as with a container. They're made up of smaller elements called components. And then a container manages everything within its ecosystem. So if you're doing any API calls or anything like that, you're going to do that within the container, and with that data, you're going to then pass that down to a component rather than component doing all that work. And then a container can then pass data called props down to its components. And then it could also pass state and all of that kind of stuff as well. So you're not going to be you're not going to be doing any logic in your component. You're going to be doing it on your containers and then passing it down as a prop. So next for the component. So the component is a reusable piece. You can reuse it in multiple parts of your application. If you have logic tied to that component, you're probably not going to be able to use it in multiple parts of your application because logic probably ties into a specific place in your application. And then it receives data and state from container. So for example, if we're turning that stove burner on, that state is going to change in the container, and then that on state is then going to be passed down to the component, which would turn the stove on. And then last, it accepts data from containers through props. So a separation of concerns allows an application to be easier to manage and provides cleaner code. So you don't necessarily have to break these down into 2 parts. You could have everything as a component. Our team, we learned the hard way. We had it the opposite way. We had all our containers have no logic, and all our components have all the logic, which started getting really hard because we couldn't reuse our components. It could only work in certain parts of the page that we were building. So when we flipped that around, it worked a lot better. It was easier to debug. We knew exactly where to go, where certain logic was happening, or if we needed to make just CSS or HTML changes, we could go straight to that component. So Redux is a JavaScript library for managing the application state. And it's composed of 3 different elements. So first, it's going to have actions. And actions has described something has happened. So for example, if a user has clicked a button, that would be your action, button clicked. This would then trigger a reducer, and reducers update the state. So the reducer tells the application, okay, when this action has happened, change the state to on or clicked or something like that. And then last, the store holds the application state. So the store it's immutable, so you can't directly change it. You would have to go through that action reducer process every time you want to change it. But anywhere in your application can get the store. So if you need certain states available in multiple components, multiple containers, you would use a reducer. And then this is just a general flow of how it would work. So first, in our UI, if we use that, button clicked, that would trigger an action that said button clicked, which would then be sent to the reducer, and then the reducer would change the state to clicked, and then that would be updated in the store. And then anywhere in your application, you would be able to get that new state. Maybe when a button's clicked, you want to change a color or you want to do a certain thing, that's what it would be used for. And then if we go back to kind of that kitchen Redux, how does it all work together? So first, a user would turn on the stove burner. So they would do this through the knob. That would trigger an action. The action would be turn on stove, and then that would be sent to the reducer. So now that stove burner is on. That's the new state. And then that state is now on, so now anywhere in the kitchen, you would know that that stove is now on. So next challenge, how do we manage our internal and external data? Redux and GraphQL. So Redux I already talked about. That's how we managed all of our internal data. GraphQL is what we used for all of our APIs. So this is all the external data that's coming into our application. We use Redux specifically to store the data from the GraphQL call, and then we would spread it out to all the containers that needed that certain data. And from a developer perspective, GraphQL was really life-changing. It might just be our situation, though. So we had, in our old service, we had all the APIs calling this monolith layer, which none of us had access to. The guy who wrote it, I'm sure, pretty much left. So all we knew was that it was calling monolith. It was making a bunch of API calls, which really took a toll on our performance. And then, some of those calls we probably didn't even need to make. And then it would take a couple seconds, and then we'd get that data back. So from our perspective, we wanted to make this really transparent. We only wanted to make the calls and get the data that we needed. And so that's why we went with GraphQL. So GraphQL is a data query language for your APIs. So what you could do is you send a GraphQL query and you get back exactly what you need. So in your schema that you have in GraphQL, let's say if you're getting user information and you only need the name, you can specify that that's all you need, and instead of getting 10 fields back, all you would get is the name. It also can get many resources in a single request. So if you need to get data from an external API, another microservice, and somewhere else, you could do that all within a single request rather than making 3 separate API calls. So if you're thinking about performance in that way, that really helps because you have to do it in 1 call rather than 3. And then Apollo Client caches your query results. So you can use a couple different clients for GraphQL. We chose Apollo Client, and what this does is when you make that call, it will cache your results back. So if you're changing views in your application or doing anything like that, it's nice because you don't have to make that API call again. It will just be cached, and then instantly your data will come up. And then last, it supports local and offline development. So if your API is down, or if something's going wrong where you can't get the data, you can use Apollo Client to mock data, and then you can get that data that would look like your real data while they're working on it or while it's down. So this is kind of an architecture, a very simplified architecture diagram of how it works. You have your devices, which will send that query to your GraphQL server. GraphQL will go to the 3 different data sources it needs to go to, get that data in a single call, and then pass it back to your device. And then these are 2 very simple query and mutation calls, just to kind of show you how it works. So on the left, queries is what you're going to do if you want to do a get call. So in this one, it's getting a feed, and here you can see that all the fields they want back is like repository, name, owner, and login. There's probably more that you can get back, but maybe that's all they need for that component. And then it directly passes that component, or directly passes that data into that component, and then you can use it right away. So that's about 20 lines of code, which isn't too bad for making a GraphQL call, getting that data, and then showing it in your component. On the right-hand side, that's a mutation. So a mutation is more for post calls. So this one's for submitting a repository. You say any parameters that you can pass with it, and then if it has anything that it returns, here created at is returned, and then that's also passed into the component. So these are just a couple really simple examples of how queries and mutations work. Again, you can see they're both 20 lines, so if you just kind of want to mess around with it, it's pretty easy to get up and started. So our team, we created this internal tool kind of for our GraphQL calls. So because we had so many different data sources, we had like SoftLayer APIs, we had IBM Cloud Account APIs, IBM Cloud Services. Anyways, we had a lot of APIs, and they had a lot of calls for those data sources. So for us, we were thinking that we didn't want to be the team to maintain this GraphQL microservice the whole time. So what's a good way to have people buy into it, but also have easy adoption and not make our team responsible the whole time? So we created a GraphQL microservice, and then from that GraphQL microservices, we let teams create their own data sources. So for example, for our microservice would have its own data source. So we got to do any queries or mutations that we needed, but they were specific for our data source. And all we had to do was update that package in our GraphQL microservice, and anyone could consume it. So this made it really easy for, if people wanted to use GraphQL, they could just use this package and have a bunch of APIs available for them already. But if they wanted to have more data sources, they could have an independent, isolated way to do that as well. And now on our team, someone open sourced it, and it's called Gramp. So if you want to check it out, it's open sourced. It has a lot of documentation, so hopefully that makes it easier to kind of learn. So how we broke down the different data sources. So first we had models. So we had 3 different files in each of them. We had models, which these are the APIs that you're going to call. So if you have like a get user, and you have to send a user ID. Get user would be your function and your model, and then your parameter would be like an account ID. And then we had resolvers. So in our resolvers, that's what contained the queries and the mutations. So as you saw a couple slides back, we just put that in one file and independent, and then it just called the functions or the models that it needed to. And then next we had a schema. So this is where you kind of put your type. So if you have get user, what types are you going to need? So probably a string for a username, integer for your number, everything like that. And then mocks. So like I said before, you can mock local data. We did it with a thing called Casual. It's just a library, it's a JavaScript library, but basically if you need a name, you could do like casual.name, and that's how we mocked all our local data. And this allowed a couple things. This allowed a central GraphQL microservice that anyone could consume. So if you just wanted the APIs and that capability, anyone can consume that. Just do like an npm install. It also created an isolated data source for each microservice. So this allowed people to kind of manage their own data sources without us having to interfere. This allowed easy adoption, so because they could just pull this in with a package, it kind of made it easier to adopt rather than have to build this all up on their own. And then last, it had better performance. So because we weren't calling a monolith and calling however many APIs it did, it definitely improved our performance. So to authenticate, we needed to create a middleware function. So this kind of goes back to how we had to authenticate with SoftLayer, we needed to get a certain token back, and that's what we weren't sure we were able to do. So we created a middleware. And a middleware consists of a series of function calls. The reason why we did a middleware was because we needed this data on the front end, but some of the information we needed was only available server side. So that's why we had to create a middleware. And in the middleware, you have an access request object, a response object, and a next middleware function. So all of these things make up a middleware, and then you're able to make changes to the request and the response objects. So we made some API calls in the middleware, and then we just sent that back with our response object. And then we were able to chain multiple functions. So if you need multiple functions, you could do however many you want in your middleware. So this would be an example of your middleware. So this is just one function, but you have your request, your response object, and then next. So this one's really easy. It just console.logs your date, whatever method that came from your request, and the URL, and then it'll go to your next function. So the flow we had, so first we initiated authentication from the front end. So to make all those GraphQL calls, we needed a token for authentication. So that's why we needed it on the front end, but we couldn't get some data on our front end. So that's how we first initiated it. Then we specified routes in our middleware. So basically from your front end, when you point to a certain API, it's going to point to a certain route, and then in your middleware, that route's going to point to the functions that you need to call. And then it performed the token exchange, and that token was sent back in the response object. And then last, we passed that user ID and tokens as props to our containers. So depending on the container, some of them needed to do GraphQL calls on render, and they needed this token, so then we would just pass it down to whichever containers needed it. So when we first initiated, we required our user ID and token in our containers, like I've said before. We just made an XML HTTP request in our component willmount lifecycle method. So you could obviously do this other ways. You could do like an AJAX call and whatnot as well. This is the one we just decided to go to for no particular reason, really. But we did do it in our component willmount lifecycle method. So I didn't touch on this, but in React, you could have lifecycle methods. Component willmount happens before your first render. So we had some timing difficulties before because we were using different lifecycle methods because we needed those tokens and that user ID before the first render. So component willmount will do that before your first render and then pass it down. So by the time it does render and make that GraphQL call, it's available. And then we specified the account ID and URL to call in our middleware layer. So we needed the account ID to get the specific token and user ID. So we needed to pass that in from the front end in our URL that we called in our XML HTTP request. And that's how that would be passed in as a request. And then we use that to then go to the specific route where our middleware was. And then we specified routes in our middleware. So we used Express router. We were already using Express, so router made the most sense. And then it was really simple, so it was just like a router.get, whatever your URL is. And then we had two functions that we needed to call. So we had get ID and then get token. And then we performed the token exchange. So how this happened was it just searched accounts to get the user ID, because you can have multiple accounts on IBM Cloud, so you need to make sure we were charging the right one. So we need to do this on server side, so we searched depending on what account it was, make sure the user ID was the same, and then we sent that ID in our next middleware function. And then we used a request library to make a post call to get that token, so that's how we got that token. And then we sent that back as a response, and then passed that down to our containers. So that was kind of the whole cycle we did for middleware and why we had to do it. So if there is a reason that you have to do it, it's pretty simple, but yes. So the next challenge was, how do we maintain clean and consistent code? So we did testing and pull request reviews. This might be hard to believe, but when I first joined the team, we had no testing and no review process for any of our pull requests. So basically, any code could kind of go in there, and no one would know. So testing will make your life easier in the long run. So testing's not the most exciting thing, or at least I don't think it's the most exciting thing to do. But in the long run, it will help you just have good code. It'll make sure everything's covered, and it will make your life easier. So we use Jest and Enzyme. So I'm going to be specifically going over unit testing with React components and actions and reducers. You could also do like functionality or functional testing. We did some server-side testing, and we also did like accessibility testing, but I'm just going to go over unit testing. So it does a couple different things. So it does shallow rendering. So when you do shallow rendering, it only tests your component. So if your component interacts with other components, it won't test like the full DOM. It will just test your component. And then you also have full DOM rendering. So this is more if you want to test lifecycle methods, test more of functionality. But this will bring up a full DOM, how it would be in the browser, and then that's how you test it. And then it has coverage reports, so it will tell you the percentage of how much your code is tested. So if you have like 50%, if you have 80%, which is really nice to just gauge how much of your code is actually tested. And then it has snapshot testing, so it'll take a snapshot of your UI, and then it will compare that in the testing, and then it'll fail if they're not the same. And then last, it just has functionality testing. So any functions you have in your code, you could test that. If a specific function changes a state or whatnot, that's also other stuff you can test. So next, for our testing, we did it with mock data. So you can mop your props and like what you would get in your GraphQL calls, because it won't actually make them for you, but you can kind of mock that data of what it would look like. We did it by simulating events. So on button clicks, if we had a certain function that happened, or if a certain state changed, we executed those that way. And then we did it for state or prop change, just to make sure all of that was working as it should. And then we tested our actions and reducers. So how you test actions is you just make sure that it has the right type, and if you have any payload in there. So just to test that it's working right. And then reducers, make sure that reducers equal the state that it's supposed to after a certain action has been executed. And then for us, we required at least 75% testing coverage. I know that doesn't sound like much, but we had a very short timeline to get this out. So for us, 75% was adequate enough for the timeline we had. And then next, so pull requests. So pull requests is probably something a lot of you are familiar with. But basically, it shows what someone has changed to push up to GitHub repository. So we required at least 2 reviews. Sometimes we would do any kind of developer and then more senior developer, just so we had 2 sets of eyes on it. We made sure that it passed all our tests in our Travis pipeline. So we used Travis for our continuous integration. I know our DevOps team used Jenkins, so it actually went through 2 continuous integration pipelines before it actually got out to production. But with Travis, you can make sure that all the linting tests pass. You have the coverage. So we had 75% coverage that we needed to meet. If it was below that, it would reject it. And then it just ensured that all code was reviewed by someone else. So last, how do we create a consistent way to configure and deploy all our microservices? So we use Kubernetes. I'll be going over Kubernetes. This won't be the exact way that we do it, because that was handled mostly by DevOps, but I'll just kind of go over, if you have enterprise software, kind of what benefits Kubernetes can give you. So Kubernetes is an orchestration tool for deploying your applications, your microservices. It automates all your deployments, and then it also manages the deployments and containerized applications. So if we think of containerizing applications, think of each microservice as a separate container, and those containers are what's going to get deployed on Kubernetes. So Kubernetes is like the home builder in charge of scheduling and managing a house. So if something breaks, your home builder will automatically go in and fix it. They manage all the scheduling, everything like that, which is what Kubernetes does with your deployments. And then just some Kubernetes definitions. So kind of the biggest element is a cluster. So that consists of the cluster master and multiple worker machines. So our cluster master is what's in charge of scheduling, what's in charge of assigning our pods, everything like that. And then the worker machines, that could be like, those are just machines, so it could be like a virtual server machine, anything like that. But that's what your application is going to run on. And this would be like a home builder company. So like I said before, it's in charge of scheduling and everything like that. And then next we have a node. So this is the worker machine that runs applications managed by the cluster master. So the node is that actual virtual machine, if that's what it's using. But the cluster master, that it interacts with the node and schedules the node rather than the actual pod. And that's more like the home builder employees. So they're the ones that will build the house. They're the ones that kind of make sure that each room is functioning how it's supposed to. And then the smallest unit is a pod. So pods usually contain one container. That's like the rule of thumb that I've heard. Because if you have more than one container, sometimes it could just overload it. So if you do one container per pod, which a container usually is a microservice, that's what's getting run. So rather than managing the actual container, Kubernetes manages the pod. That's an abstraction of the container. And that would be more like your room. So each room would be a pod that you deploy. So Kubernetes at an enterprise scale. So these are some of the things that Kubernetes can help with. So what happens if my app crashes? I'm sure everyone's kind of gotten like a late night call about an application crashing, and no one likes that. Next, how can I roll out updates or rollbacks? So if we deployed on every Thursday, but sometimes, an update can have a bug that you need to roll back really quickly, or if you just need to get updates out weekly or however you do your deployments. And then next, what happens when I get a high influx of traffic? So if you just get a lot of visitors to your site and you're not expecting it, what can Kubernetes do? And then what will work best for my microservice architecture? So this point, when I talk about it, it's not really Kubernetes specific, but it works well with Kubernetes. So what happens if my app crashes? So it provides monitoring for pod health and restarts them in case of failure. So it's always monitoring your pod, and if it fails, it'll automatically restart them, which is really nice, because then you don't have to go in and manually restart them yourselves. And then how can I roll out updates or rollbacks? So you can roll out an update or roll back, and then what Kubernetes will do is it'll incrementally update the pods with the new ones. So rather than taking all your pods down and deploying them back out, it will incrementally do it one by one, so then you have no downtime and your user won't notice that you're deploying a new update. And what happens when I get an unexpected high influx of traffic? Kubernetes will automatically scale the number of pods in your deployment. So if you have a lot of visitors, it'll automatically scale that, and you don't really have to do anything on your part. And then what will work best for my microservice architecture? So the microservices can be packaged into containers, which are then in pods and then deployed all together individually. So how we had our deployment schedule, all of our microservices was a pod, and they would deploy them all out on Thursday. But let's say if one team needed more time, they could just deploy that pod. And it just worked well with all the different microservices we had. So at the end of it all, we increased conversion by over 250%. So from a business perspective, the conversion was actually ordering the virtual machines, and virtual machines cost a lot of money. So when we increased that conversion, from a business perspective, we increased our revenue. So from the business, it was really happy. And from that, I think our customers liked that experience better than the original. And then we created a standard for future teams to follow. So like I said before, There was no testing. We had a lot of monolithic microservices. So this just created a standard that anyone can kind of take and then build their own microservice and follow, hopefully best practices. So this is just a quick recap of what I talked about today. So if you want to use React to build your components and containers, and then you can use GraphQL to make those API calls and then cache those results. And then use Redux to store the information you got from GraphQL. And then if you need to use a middleware, and then make sure to test and review everything, and then finally you can deploy it on Kubernetes. And then just the last bit, so Phil, I work with Phil at IBM. He's giving the keynote tomorrow morning. So you guys should check it out. He's talking about like the future of Docker and more about like serverless and IoT, so it should be a really good talk. But it's the first one tomorrow morning. And I just want to thank you all for listening to me. If you guys want these slides, they're available there. And I'm also on Twitter if you have any questions. And these are just some resources. So my slides, I have an open source GitHub repo. It has everything I talked about except for GraphQL, which I'm planning on adding within the next month. It's very simple to what I talked about. So if you guys just want to pull that down and mess around with it, and then just more information on like React and everything I talked about below that. Yes, so any questions?
We have some time. We have quite a bit of time. So this is your chance for some questions, guys. There we are. It's either a question or he's greeting someone. Hello. He's also. Are you saying hello or are you question? It's a question.
Hello. Two questions. One, did you actually code review every single piece of code you wrote?
Did I
Not
personally?
you personally, your team.
Oh, yes. So in GitHub, we use GitHub, and we made it required 2 reviews before it could be merged. So there was no way to merge it unless it was reviewed. So
Is there any tool that measures how much of your code has been code reviewed, like the test coverage?
wait, what was that?
Is there any tool that measures how much code has been code reviewed so that you know that you actually tested 100% of your code?
Yeah, not that I'm aware of. I think we just kind of trusted our team to make sure that they were reviewing that code when they said they would, and kind of having that second reviewer kind of made that probability a bit more. But yeah, so we just trusted our developers to make sure that they actually reviewed it.
And the other question is, I didn't get how exactly you managed to incorporate every single piece of data you needed into the GraphQL system. You had several different kinds of data sources that you needed to match into one GraphQL query. So how you combined all these data sources into one query? How did you get your input from your different data sources? I didn't get that.
So the question was, how did we manage to bring in GraphQL?
To merge all the different data sources, to merge them into one query.
So how did we manage to make one query?
Yes.
Okay. So for each API call that we had, it was a different query. So depending, we had some helper functions that I didn't go through, but with the helper functions, so in our React component, we would make whatever, so those models, we would make whatever call to which model we wanted to go to, which was in the package, and then that would specify what query it needed to call. So for each call, it was a different query. It wasn't all like one query. Does that answer your question?
Yes, but you have different separate data sources below you had one call, and I suppose from what you said that you had different data sources between, and you had to combine all the different data sources from one call into another. But probably I'll need to read something about GraphQL before I ask.
So how did we call the different data sources in our GraphQL microservice?
Yes.
Right? So in our GraphQL microservice, we had different NPM packages, and each one of those packages would be a data source. So we pulled it into our main microservice GraphQL, and those had helper functions to then connect to the specific data source, and that's how we pulled it all in.
Okay, thank you very much.
Yeah, and if you want to check, you can check out Gramps. You could actually see the code and test with it and stuff. That might kind of give you more clarity.
Okay, thanks.
You're welcome.
Hi, thank you for your presentation. I have one question. So as you told us, the GraphQL was running in a separate microservice that you created. What if Kubernetes sees that the bottleneck is in this microservice and spawns another instance of GraphQL? So you have two instances of this microservice running, which means that the data cached in the one should be similar to the data cached in the other. How is this handled? Is it automatically done by GraphQL, or did you do load balancing mechanisms?
So we didn't run into that issue ourselves. What we had to do was every time something was changed in GraphQL, which was quite often at the beginning, we would have to update our version number in our microservice, which then kind of spanned out as releases. And then for each of those release, we redeployed it. So I think maybe because we were doing it, I think about every week at one point, we didn't run into that. But you could probably see if there's multiple instances running, you could probably just kill one of the pods because you could probably see that it's running twice. I'm not sure how that would work with the data and whatnot, which microservice or which pod it would call, but I could probably find out if you meet with me after. I could probably find out the answer. I could ask someone on the team.
Okay, thank you.
I think we have time for one more. In fact, maybe two more. So,
hello. By the way, great presentation.
Yeah.
So I had one little question, one very small detail. You said at the presentation that you have a component, and once you are loading it, once the component did mount, you do an AJAX request. I don't know if you remember.
Yes, so it was in component willmount. So that happens, yeah. So we call this function to do the XML HTTP request, yes.
Okay, so I wanted to ask you, so do you think that this is a good practice? Because I have it in mind that this should go mainly, so the logic should go to the Redux rather than the component. And also React, for example, said that the willmount will be unsafe to use it anymore. So, but let's forget about that. Let's say about the view to have logic inside. What do you think about that? Is that, I just want to understand the logic behind the decision that you made, mainly.
Yeah. So I remember when we were first doing it, we didn't want to do in component willmount because we saw that exact thing, that it wasn't safe. But the other lifecycle methods, we had timing issues. So it would render before we could get the tokens to all of the containers, which then we couldn't make the GraphQL calls. So at the time, we probably need to go back and change it, but at that time we were kind of on a strict timeline, so we were like, let's just do it this way and just get it working and then come back to it. So there probably is a better way we could do it, but...
Okay, fair enough. Okay, that's it.
Good. Well, thank you very, very much. Thank
Thank
you.
you.
Big round of applause.